Good morning, all of you. So this is the second video of generative design. So this is the second example, that is ALCOA bracket. So I will click on this data panel, go to this home and click this generative design samples. Here the fourth option, ALCOA bracket. Double click this. This is again a bracket. This is actually a bearing bracket that is used in aircrafts, control surfaces of various aircrafts. So this is actually a dynamic component, and this is actually interacted with other parts in the aircraft. So this this bracket how to sustain large loading forces in various directions. So as this bracket is actually a part in the aircraft or used in the aerospace industry or in the aircraft. So weight savings or minimize the weight or reduce the mass, reduce the weight, that is very important. So weight savings is very important. So that means you can reduce the fuel consumption of airplanes. Also, this should satisfy the technical requirements also. So in this tutorial, in this example, we have to redesign this existing bracket. Okay, so we have to redesign the existing bracket. Okay, so I will go to this generative design option. Okay, so then like the previous example, GE bracket, the steps same. Okay, so I will change the units. Click this here. I will change the unit system to US inches. I will click OK. So first of all, I will open this ALCOA bracket and then I will save this. Okay. Then I have changed the unit system. Then I will change the resolution, that is click study settings, or from here right click here and you can change the study settings as normal. Click OK. Okay. Then next is you have to define the design space. Okay. So here you have to given the preserve geometry. That means that geometry there is no change. There is no change from the beginning to the end. There will be no change. Okay. That is called a preserve geometry. Obstacle geometry means that is the design space means it is the combination of preserve geometry, obstacle geometry, then starting shape, etc. That means obstacle geometry means empty spaces. That actually represents the empty spaces where material isn't placed during the generation of outcomes. Okay, so that is actually the obstacle geometry. That means empty space. Obstacle geometry means empty space. Then next is the starting shape. So starting shape means this is again a type of geometry, like say preserve geometry, obstacle geometry. Starting shape, this is again a type of geometry, and this geometry will be modified according to the goals and constraints during the generative design process. Okay, so this starting shape is actually optional. These are the three important: preserve geometry, obstacle geometry, and starting shape. Okay, so preserve geometry means this incorporate bodies in the final shape of the design. That means these bodies don't change during the generation of the outcomes. Okay, that is the preserve geometry. No change, don't change during the generation of the outcomes. Obstacle geometry means that actually represents the empty spaces where material is in place during the generation of the outcomes. Then starting shape means uh, this is a type of geometry, and this will be modified according to the goals and constraints during the generative design process. This is starting shape is actually optional. Okay, so here I will click this starting shape, and I will select this as my starting shape. Okay, then I will click OK. So here you can see the color yellow color. This is the starting shape. Then here I will click this model component. So here you can see this original shape. So this is the original shape. Okay, and I will here you can see the starting shape. Yeah, so this is the starting shape, and as well as this is the original shape. Okay, this is the starting shape, and also this is the original shape. Okay, then I will switch off the visibility of this. Then I will switch off the plate. Then I will give the preserve geometry. Okay, so go to design space, preserve geometry. So this bolt flange 1, 2, 3, and 4. Okay, so these 4 bolt flanges and this pin bearing. This pin bearing. Okay, so these 1, 2, 3, 4. These 5 are the preserved geometry. That means there is no change during the generation of the outcomes. Click OK. Okay, color you can see green color. That means that these 5 represents the preserved geometry. Yeah. Yeah. Next is the obstacle geometry. Okay, so go to design space and obstacle geometry. Click OK. Okay. Okay, so here you can see, so this is called design space. Okay, so this is the design space. So in the design space you can see the preserved geometry, the obstacle geometry, as well as the starting shape. Then next is the design conditions. Okay, so again I will switch off the visibility of starting shape, and then I will change the visibility of plate. Yeah, so I will apply the constraints, go to structural constraints, select this face, this face, this face, and this face. Okay, see, in the first video I have explained we can give structural constraints to only the preserved geometries only. Okay, so I have applied structural constraints fixed for faces ux, uy, and uz. Click OK. Okay, then okay, yeah. Then next I will apply the load, structural loads. I will select this face, then select type force, then direction type fx, fy, and fz. Okay, so I will enter the fx value as 1250. Then click OK. Okay, so now you can see load case 1. So I will right click this load case 1 and clone load case 2 times. Now you can see load case 2 once more, load case 3. So load case 1, load case 2, and load case 3. Then I will select this load case 2, and then I will edit this. Okay, so I will edit this fx, I will enter fx as say 662 and fz minus 662. Click OK. Then I will go to load case 3, loads, force 3, fz as minus 2500, minus 2500. Click OK. Okay. Then next I will go to this design criteria. That means the objectives. Okay. So I will go to this design objectives. So the objectives are mass, minimize mass. Okay. Or maximize the stiffness. Okay. So if you click this maximize stiffness, that means if you are maximizing the stiffness of your bracket, what happens? Maximum stiffness means you can increase the mass. Okay, so you can fix the target, mass target, with a factor of safety. With you can input the factor of safety value. Okay, so here either you can minimize your mass with either you can minimize the mass with a factor of safety, or you can maximize the stiffness with a mass target with and a factor of safety. So here I am using the minimize mass with a factor of safety 2. Then click OK. Then go to design criteria manufacturing. So unrestricted additive. If you are interested in if your work is in manufacturing, will be in milling operation, you can select this, or 2-axis cutting, die casting, etc. So now I will select unrestricted plus additive. I will click OK. Then I will go to materials, study materials. Okay, so I will add materials. So I will delete, first I will delete this, then I will select stainless steel, AISI 446, stainless, yeah, here it is. Yeah, stainless steel AISI 446. Then next is 440C. Then the third one, that is the titanium 6Al4B. Close. Okay, so here you can see the manufacturing. Okay, materials, you can see stainless steel, ASI 446, 440C, and titanium 6Al4. Okay, so I have applied everything. So I have given all the loads, constraints, objectives, manufacturing operations, materials, preserved geometry, obstacle geometry, then starting shape, etc. Everything. Okay. Then next I will go to generate and the generate outcomes. So as I explained in my last video, so this actually requires 33 credits. Okay, so you just go to this data panel, the already generated outcomes in this folder. Okay, so here you can see ready to explore. So here you can see ready to explore. Double click here, ready to explore, and here explore ALCOA bracket. Double click here, explore ALCOA bracket. Or you can directly click here and you can generate this, no problem. Okay, so click here and you can see the explore option is there. Yeah, here you can see explore generative results. Click here. Yeah, here you can see this set of designs. Okay, so as I explained in the first video, what is generative design? Generative design means you are defining a design problem. You are actually defining a design problem with some constraints, with your goals, with your constraints. So your what is your objective? Your objective is to minimize the weight. Okay, minimize the weight saving, such that you can reduce the fuel consumption of airplanes. Okay, so so your goals, your constraints, according to based on your goals, based on your constraints. Okay, you are based on your goals, based on your constraints, the you can see a set of designs generated. So these are the set of designs. So here these are the set of designs generated, and you can explore all the designs, and you can select the optimum one for manufacturing. Okay, so I will sort this by using mass. Okay, I will click sort, and then I will click this mass. Okay, you can see this is the lightest mass. Okay, okay, 0.496, and here you can see this is 1.28. Here in the slider you can see the minimum, the lightest will be 0.496 pound, and here this is 1.281 mass. Similarly, if you want to sort using displacement, okay, so what is the displacement? Okay, 0.022 to 0.05. Okay, so in this way you can, in this way you can sort this. So again I will click the sort, and then I will click mass. Okay, so I will select one design. Okay, say for example, say I will select, say, this outcome 9. I will double click this outcome 9. Okay, so this is, yeah, this is my outcome 9. So here you can see, you can see the preserved geometries. Okay, so I will click show and preserve geometry. So these are the, these 1 2 3 4 5, these are the preserved geometries. So here you can see no change, no change from the starting to the end of the output generation of the outcome. That is called a preserved geometry. Okay, so where is the obstacle geometry? So here this is the obstacle geometry. Okay, then where is the starting shape? So this is the starting shape. Okay, so this is the starting shape, initial starting shape, or the original shape. Okay, and this is the final one. This is the final one. Okay, so here this is outcome 9, and here in the bottom you can see, yeah, in the bottom you can see iteration. So now this is the iteration 15, this is the final iteration. If you want to see the 10th one, click here 10, you can see the 10th iteration. Okay, so again I will go to the 15th iteration. Okay, once it is finished, you can click this finish. So again click this. Okay, this is the, again this is outcome 9, and here you can see in the right side the various properties. So here what is the mass? 1.026 pound mass. Okay, you can see the properties, and the factor of safety is 2. Okay, factor of safety limit is 2, and here the minimum factor of safety is 1.6. Okay, so here the limit is limit I am given as factor of safety as 2. Okay, then I will click this finish button. Okay, so you can click properties view for getting the properties, then scatter plot view, then also the table view. So this is the table view. Okay, so finish explore, then go to this, go to generative design samples, then double click on outcomes. Okay, so outcome already they uh, generated. So I will click this outcome one ALCY bracket, double click here. Yeah, this is the outcome one. Okay, this is ready for manufacture. You can go with this manufacture. Okay, so right click here, properties, what is the mass? Mass will be say point, so I will change the amount. So right click here, properties, so 0.493 mass. So physical material titanium 6L48. Okay, so in this way you can define your design problem. You can define your design problem and you can give the constraints, the goals, and this generative design will give you a set of designs. So these are the set of designs, and you can explore the various set of designs, and you can select the optimum one for manufacturing. Okay, so practice this second example. So first example is GE bracket, then the second example is this one, ALCY bracket. So do this. Okay, thank you.